Hi all, let's start with Unit 4. The first part of Unit 4 is a memory architecture or memory organization. The first topic is a memory hierarchy. So in today's lecture, we are going to discuss about an introduction to memory hierarchy. What are the components of a typical memory hierarchy and memory hierarchy in a computer system and the characteristics of a memory hierarchy. So coming to the introduction, so as we know, the memory unit is one of the most essential part in a digital computer because it is used for storing your programs and data. So if you consider a computer with a limited application, it can be able to fulfill the intended task without the need of any external storage or additional storage capacity. But if you consider the most general purpose computers that are used in nowadays, they work efficiently only if they are equipped with some additional storage beyond the capacity of your main memory. As we know, the main memory is the main component of your computer, which is responsible for storing your data and programs which are required by the CPU during the execution. Whereas the other types of memories are needed as a backup storage. So apart from the main memory, you also require some additional storage capacity present in your computer to store the backup information. Because there is with the help of a main memory, you cannot accommodate all the programs and data that is present in a computer, and there is no enough space in the main memories to store the entire information. So, and moreover, most of the computer users, they are nowadays they are accumulating large and large amounts of information as well as the data processing softwares. So to store all this type of information, all the accumulated information may not be needed by the processor or by the CPU at the same time. You cannot place this type of information in the main memory. So it is more economical to use some low cost storage devices such as your hard disk in order to back up the information or for storing the information that is not currently used by the CPU. So coming to the components of a typical memory hierarchy, you see here the main component of a typical memory hierarchy is your main memory, cache memory. These two are internal storage memories that are present in your in your computer. Whereas we also have some external storage devices such as your auxiliary memory, which is the magnetic disks and magnetic tapes. So coming to a main memory we also call it as a primary memory or a volatile memory, or this is also called as a random access memory. It is volatile in nature because once the power is switched off, whatever contents are placed in the main memory, they are being erased. And it is called as a random access memory because in order to access any information in this particular memory, it can be accessed randomly and not in a sequential manner. So we call it as a random access memory. And one more thing, in the main memory is one of a memory which is present internally in your computer where the CPU can interact directly. So if the CPU wants to execute any of the programs, that particular programs has to be placed into the main memory so that the CPU can access the particular information from the main memory and execute them. So apart from the main memory, we also have a cache memory. So, what is the role of a cache memory in a computer system? So, when you have a main memory, why do we need a cache memory? Say the main use of a cache memory is it is one of the fastest memory in terms of access speed. Accessing the cache memory is very fast compared to accessing your main memory. The reason is it is very directly, it is very near to your CPU, so that the CPU can access this cache memory easily or fastly when compared to accessing the main memory. So, what type of information can be present in the cache memory? The information which can be accessed most frequently by the CPU. When you compare the storage capacity of your main memory and the cache is very small memory, but it is very fastest memory compared to your main memory. So, compared to the cache memory, the size of your main memory is large. So, since it is of very limited capacity, you cannot place more and more amount of information in the cache. Only the amount of information or your programs which can be or the instructions which can be accessed most frequently by the CPU can be placed into the cache memory, because the CPU can access them very quickly compared to accessing the main memory, because it takes a little amount of time to go to main memory to access it and get back. So those type of information that are most frequently accessed by the CPU are placed in the cache memory. So it is one of the fastest memory, but the size is very limited. So next comes the next type of memory. Components of a typical memory hierarchy is the auxiliary memory. So examples of auxiliary storage devices are your magnetic tapes and magnetic disks, which are mainly used for backing up your information. So these are the components of a typical memory hierarchy. And we also have an input output processor. So the input output processor is nothing but it acts as an interface or intermediary. It allows a communication between the auxiliary memory and the main memory. So say you cannot place all the information or bulks of information into your main memory. And moreover, main memory is a volatile memory. The contents of the particular memory will be erased when switched off. So when you want to provide a backup of information that has to be stored permanently in your computer, that can be stored in the magnetic disks. The example of your magnetic disks are your hard disk. So whenever a program or a data is required by the CPU, it will be transferred from the magnetic disk or your hard disk into the main memory, so that the CPU can access a particular information. At the same time, if any information or any data is not required by the CPU, which is present in the main memory, that can be transferred back into your magnetic disk or your hard disk. So the input output processor it helps in transferring the information between your auxiliary storage devices and your main memory. So these are the components of a typical memory hierarchy. So the total memory of your computer, it can be visualized as a hierarchy, where the hierarchy consists of all the storage devices present in your computer system, and which starts from slow but high capacity auxiliary memory, such as your hard disk or magnetic disks and magnetic tapes, to a very fast, relatively fast main memory, and to even smaller and very fast cache memory, as well as the registers, which are accessible to high speed processing logic. So if you consider the hierarchy of a memory, they are made, all the memories of your computer system, they are arranged in a hierarchical way, where if you look from top to bottom, the devices which are placed at the top of the hierarchy are very fast in terms of speed, accessing speed, but in terms of its capacity, they are very small. And which are placed at the bottom of your hierarchy, they are very slow in terms of accessing speed, but in terms of a storage capacity, they are very high. So they are placed in a hierarchical model where the registers are placed at the top of your hierarchy and the auxiliary storage devices such as your magnetic tapes are placed at the bottom of your hierarchy. So let's see the hierarchy. First is registers, then next comes the cache memory, main memory, magnetic disks and magnetic tapes. So the computer memory can be divided into 5 major hierarchies based on the use of the memory and the speed. So which are registers, cache memory, main memory, magnetic disks and magnetic tapes. So if you look at the bottom of the hierarchy are the relatively slow magnetic tapes. Next are the magnetic disks, which are used for a backup storage such as your hard disks or SSD solid state disks. These are called as a magnetic disk. Next comes the main memory, which occupies a central position in order to communicate directly with your CPU. So, and as well as it can also communicate directly with your input auxiliary memory. So, with the help of an IO processor. So, when the program not residing in the main memory, which is needed by the CPU, they are brought in from the auxiliary memory or your hard disk into the main memory. Similarly, the programs which are not currently needed in the main memory, they are transferred into the auxiliary memory such as your hard disk in order to provide a space for your programs and data that are needed by the CPU. So let's see each and every memory in detail. The first type of memory which is at the top of your hierarchy is the CPU registers. We can call the CPU registers also as an internal processor memory, and the data or the instructions which has to be executed has to be kept in these particular registers. We have a list of registers present in our computer, like your instruction register, address register. So all these registers are considered as your CPU registers. So the register is usually a static RAM, SRAM, in the computer processor that is used to hold a data word, which is of typically of size a 64-bit or a 128-bit. Next comes your main memory. So main memory, we call it as a CPU memory or your primary memory that can communicate directly with your CPU. And it is called as a primary storage unit of your computer system. And when you compare the speed, the main memory is very fast and very large memory that is used for storing the information throughout the computer operations. It is made up of the main memory. It is made up of RAM as well as ROM. Some amount of main memory consists of ROM. You will know in detail about what is a RAM and ROM. Next type of storage is auxiliary memory. So auxiliary memory are the devices which are used to provide a backup storage of your information. And the most common type of auxiliary memory devices that are used in your computer system are your magnetic tapes and magnetic disks. So magnetic disks are nothing but your hard disks or your solid state disks. And magnetic tapes are which are used in the olden days to provide backup of your information. Then nowadays we are using magnetic disks, and they are used for storing your system programs, large data files, and other types of backup information. And only the programs and data that are currently needed by the processor or the CPU they reside in the main memory, whereas all the remaining information which can be stored permanently in your computer, they are stored in your auxiliary memory, and they can be transferred into your main memory when and where required by the CPU. So the other important type of your memory is your cache memory, which is employed in a computer system. And the main role of a cache memory is to compensate the speed differential between your main memory access and your CPU. So if you consider a CPU, if it wants to access any information, it requires certain time to access, because accessing the main memory takes a much amount of time compared to accessing your cache memory. Say for example, if I have a for loop for I is equal to 0, I less than 100, I plus plus, I have to execute one printf statement. In that case, this for I has to be accessed more and more number of times, right? That is particular instruction, the instruction that is present in the for loop, that has to be executed more number of times frequently, right? In that case, when those type of instructions have to be executed by the CPU most frequently, rather than placing them into your main memory, they can be placed into the cache memory, because you can access the CPU can access the cache memory fastly than executing the main memory. So the cache is used for storing a segment of programs currently being executed in the CPU and the temporary data which is frequently needed by the CPU. So most frequently accessed information or your instructions can be placed into the cache, so that it is easy for the CPU to access those type of instructions rather than accessing the main memory for each and every time a particular instruction has to be accessed, which takes more and more amount of time. So the multi-programming is nothing but, if you look at the many types of operating systems, they are designed in such a way that they can process a number of independent programs concurrently at the same time. So this concept of operating system, we call it as a multi-programming. The operating system is designed in such a way that it can able to process multiple independent programs at the same time. Multiple programs has to be executed at the same time. Say for example, there are 5 programs which are executed in concurrently by the CPU at the same point of time. In that situation, what happens, all the 5 programs which are required by the CPU has to be present in the main memory. But if you consider one of the program, it is too long, it cannot be accommodated in the available main memory space. So in that case, a program with its data normally resides in your auxiliary memory or your hard disk. So when you have your program size which is too long and you cannot accommodate into your main memory, what we can do is, rather than placing the entire program into your main memory, you can take a segment of program which is required by the CPU at that point of time, and only that can be transferred into the main memory. So this part of computer system that supervises the flow of information between your auxiliary memory and the main memory, we call it as a memory management system. So when you have a concept of multi-programming implemented by an operating system, you can, in order to accommodate the memory space for the multiple programs at the same time in the main memory, it is the responsibility of the memory management system to supervise the flow of information between your auxiliary memory and the main memory. That is done by memory management system. So next, coming to the characteristics of a memory hierarchy. So with respect to the different types of memories that are present in the memory hierarchy, each and every memory has certain characteristics. So there are four characteristics here with respect to the memories. One is capacity, second one is the access time, the third one is performance, and the fourth one is cost per bit. Let us see what each characteristic and how it affects the different types of memories. The first is characteristic. So what does capacity refer to? It refers to the total volume of data that a memory can store. So no matter what type of a memory it is, whether it is a register or a main memory or a auxiliary memory, capacity refers to the total amount of information or a data that the particular memory can store. So if you look at the hierarchy from top to bottom, the capacity increases moving from top to bottom in the hierarchy. So if you look at the hierarchy, the top of the hierarchy contains your CPU registers. Next comes your cache memory, main memory, magnetic disk and or hard disks, or optical disks and magnetic tapes. If you consider the capacity in a hierarchy, in case of a CPU registers, they can store a capacity only in the form of bytes. Whereas a cache, it can store the information in the form of kilobytes and megabytes. And a main memory, it can store in the form of GBs, and hard disks and store in the form of terabytes. So if you consider the hierarchy from top to bottom, when you move from top to bottom, the capacity of your memories increases. The CPUs are very small, where the storage capacity of registers are very small, which can store the information only in the form of bytes, okay, which is at the top of your hierarchy. So the capacity increases moving from top to bottom in the hierarchy, from registers to cache, cache to main memory, and main memory to the secondary storage device. So next characteristic is the access time. So access time refers to the time it takes to retrieve any information or a data from the memory. So how fastly you can access the particular information from that particular memory. That is nothing but your access time. So which increases as you move down the hierarchy. Access time. So faster memory like registers and cache have shorter access time, while slow memory like your hard disks, magnetic tapes, they are very slow in accessing the information. So in terms of accessing the information, when you move from top to bottom, accessing the information from the registers is very fast compared to accessing the information from your auxiliary memory. So next comes your cache memory, which is fast in accessing the information. That is the reason the CPU places the most frequently accessed information into the cache, so that the access time is very short compared to your access time of your main memory. Next comes your main memory, and next access time of your hard disk is large compared to your access time of your main memory. And finally, accessing your auxiliary storage devices like your optical discs and magnetic tapes, the access time is very large compared to access time of your CPU registers. Next comes your performance. So a memory hierarchy always aim to improve the overall system performance. How does it improve the performance of your system? By ensuring that frequently accessed data is placed in a faster memory, such as your cache memory. So that it reduces the time taken by the CPU in order to retrieve that particular data. So when not all the types of information can be placed into your main memory. Similarly, not all the types of information can be placed into your cache memory. So A memory hierarchy is designed in such a way that whichever instructions are needed by the CPU most frequently, those type of information can be placed into the cache, whereas the other type of instructions or data can be placed into your main memory, so that it increases the performance of your system. Next characteristic is the cost per bit. Bit is nothing but the cost of storing a single bit of data into your storage or a memory or your storage device. So if you look at the hierarchy, it generally increases as you move up in the hierarchy. So the registers and cache are said to be called as very expensive, whereas your main memory and secondary storage devices are more cost effective. So if you look at the hierarchy in terms of cost cost per bit, auxiliary storage devices such as your optical discs, magnetic discs are very cheap compared to your hard disks, whereas your main memory is very costly compared to your hard disk. And cache memories are very costly compared to your main memory. And CPU registers are very costly compared to your cache memory. So the cost it increases when you move from bottom of your hierarchy to the top of your hierarchy. So if you look at this CPU registers and cache memory, we call them as an internal memory. Where if you look at the main memory, that is called as your primary memory, and magnetic disk or your hard disk is called as a secondary memory, whereas your optical disk is called as your optical disk, such as and magnetic tapes are said to be called as your auxiliary memory. So optical disks are nothing but your DVDs and all. So this is a typical memory hierarchy. Thank you.